Hi everybody, it's Rebecca, and I know that I promised you guys this video a while ago because my first explanation of genetics and how they relate to albinism wasn't the best because I was trying to answer the question as fast as possible when I should have just started from the beginning. So that's what we're going to do this time, and I've written everything out ahead of time, and I've been trying to get more comfortable with my camera and how everything is backwards to how I think it is, but I still haven't mastered that. But this time we're going to do it from little ghetto sheets of paper since I don't live in a lecture hall. I totally wish I did. As soon as I get them oriented. I've been practicing for the past few minutes trying to get these right. Okay, capital P in our situation is going to be somebody who is pigmented. Lower P is lack of pigment. So these are our two genes, pigment and lack of pigment. And two P's means somebody who is dominant. And homozygous, homo being the same, zygous referring to the gene trait, for pigment. And then we have heterozygous, which is hetero being different, zygous being the gene again, for pigment and not pigmented. This person, since pigment is the dominant trait, will still have pigment in their skin, but they will be a carrier of albinism. And then the two little lowercase p's are lack of pigment completely, and that is homozygous recessive, recessive meaning the trait that isn't as strong and won't show up unless there's two of it, for albinism. The model that we're using again is called a Punnett square, and we are looking at the heritability, the ability to inherit albinism. So here we have two parents who are both homozygous for the dominant trait. And all of their children, see how it's kind of like clear across the board, everybody's not albino? Nobody has albinism because mom and dad don't have any genes to give you any albinism, so no albinism there, and that is pretty much run of the mill. And then here's a different situation where none of the children will have albinism, and this is when one parent is heterozygous and has a gene for albinism but doesn't display it, and then the other parent has two genes for pigment, so they won't have children with albinism. Like, these two wouldn't have children with albinism because the children will either have both dominant genes or they will be carriers, but no one would display albinism. Now this next one is what happened in my case. Both of my parents aren't albino, but somehow I popped out, and what happens here is each parent has one dominant and one recessive trait. They're both heterozygous, and mom and dad could have a child who doesn't have any of the recessive traits, or they have a 50% chance of having a child who's a carrier, or a 25% chance of having a child who has albinism. And when I say chance, I mean, like, you could have parents who have two albino children and one child who doesn't have albinism in a situation like this. A chance is kind of like rolling the dice. Like, the gender of your children is determined in the same way except for with X and Y instead of dominant and recessive. And you have a 1 in 4 chance of having all three children if you have three the same gender. A 1 in 8 chance that they'll be all girls, and a 1 in 8 chance that they'll be all boys, like my dad's family had 3 boys. Genetics is basically a roll of the dice. Just because you hit this percent more than somebody else does or less than somebody else does, it doesn't mean that the idea has changed here. It just means that you were either lucky or unlucky, or however you consider it, in one way or the other, and just something happened. Alright, and the next one is a person with albinism, the double recessive trait, with somebody who is heterozygous for albinism. So, person with albinism and person without albinism have a 50% chance of having a child with albinism and a 50% chance of having a child without albinism. This is why you can, like, either have albino children or not when you have albinism. Factors like this. And then we also have a situation of, but Rebecca, how about those albino people who never have any children with albinism? This is most likely the situation there. One parent with albinism and one parent who is homozygous for the dominant trait, so that all of their children will be carriers, but none of them will have albinism. There's a high chance that somebody later on in the family could have albinism. In some families, you don't have people for generations who have albinism. My mom told me about one family who she'd been talking to who they hadn't had albinism in their family for 8 generations when it suddenly came back up. In my family, we can't even note anybody who's had albinism in a really long time. Like, we don't know of any relatives who ever had it, so. And then there's always the chance that you could have 2 parents with albinism, and then there's basically an 100% chance that the children will have albinism. There can be several genetic flukes, but that is the cut and dry science way to explain it. So that's one reason why having albinism is rarer than not having albinism, because the dominant trait always takes over the recessive trait. So it's kind of like whether you have curly hair or straight hair. This is one of those things that it's not sex linked. So albinism can occur just the same as in men as in women and things like that. So that is the more organized version of my little genetics bit, and hopefully I will think of some lovely stories about albinism, and we'll have albinism story time soon, because I'd like to upload some more videos, because I feel kind of unproductive since I left you guys for such a long time, like most of this semester, and I'm totally procrastinating from my exam studying right now because I've already studied a lot today. So see you guys later!